Okay, everyone. Yes, we're ready to start now. We got the everything worked out. This is my presentation called Exploiting Scada Systems. And brief background, well, my name is Jeremy Brown, and I'm a vulnerability research engineer at Tenable. And I like to play with Scada software, so the presentation is focused on vulnerabilities in Scada software. So let's get started. So a lot of Scada software runs on AIX, OS2, Linux, but most of the modern software runs on Windows. So the framework that I'll be demoing later will show exploiting the Scada software on Windows. So Scada software used on workstations, you can use it on remote. There are even mobile apps to control remote aspects of Scada, and that's what the iPhone app shows. So attack vectors via software vulnerabilities. With Scada software, they're used the same. They're in the same programming language as a lot of the other applications, C, C++. So they share the same vulnerabilities as any other application. So whether that be client-side attacks from the web browsers, click on a malicious link, anything like that, whether it's not patched, email, or even malicious servers attacking clients, Scada clients, and things like that. Also server-side attacks from the internet. If Scada software is connected to the internet, it's vulnerable as just anything else, or the internal network if it's firewalled or not accessible by the internet. So I'm just going to skip through just some of the brief introduction. Clickjacking, I thought that would be funny. Like, you never know, maybe it's vulnerable to clickjacking. You never know. So what's wrong? What's the problem with Scada software? Well, security has been implemented as an add-on instead of being built around the product from the ground up, especially for a lot of the older versions of software. And Scada plants and things, the security is kind of a hindrance. So it wasn't really built. Everything back then was kind of built just to be easy for the operators. So security wasn't really a priority until people figured out people were hacking into Scada systems. And then systems typically are installed for long term, and software upgrades may require new hardware. So when Scada systems are installed, they are put there for maybe a decade, 5 years, a decade, 2 decades, something like that, for a long term. So when they put everything together, they're not looking to make upgrades for a long time. So if vulnerabilities come out, or patches, or new versions, they may require new hardware just to upgrade. And then just kind of thing that I noticed that may be typical for a lot of Scada systems, when they go into an audit or something like that, a lot of administrators are saying, this isn't connected to the internet, or they can't access this from this network because it's separated, or on a different network, on a different subnet, something like that. But still, something somewhere is connected to something that may be connected to the internet. The whole process of communication means you can communicate with things anywhere. You got to be able to communicate it with, to control it. So unless it's strictly physical access, something's got to be connected to something, and a lot of times it's also connected to a system that's connected to the internet. So if an attacker gets control of a system that has access to the internet, he got access through the internet, and got access to the internal network. So even though the system wasn't connected to the internet, it is now vulnerable to attack from the attacker. So. And then vendors can take their time with updates, and managers can take their time updating. Since they're going to be in place for a long term, a lot of the patches and a lot of the upgrades may not occur for a long time. So even if you find bugs in Scada software it could be 5, 10 years old, or even the latest software, you still have a chance to attack something on the network, because chances are they haven't upgraded for so long that it's still going to be vulnerable. So. And through my research, I found that there are a ton of vulnerabilities in Scada software. It's just, I don't know if they're not, I guess a lot of the old programming practices have to do with this too. And it's just, they're not, the code is not secure. Plainly saying, it's not. They should really do some in-house testing, because you could simply, I mean, some of the vulnerabilities I've found, I've opened up a hex editor of the file format that happened to be used in the Scada software, looked at an interesting place, and put a bunch of characters, a long string in there, closed it, saved it, closed it, ran it in the software, crashed. It's just, it's not stable in the security aspect. So just kind of, who may find the bugs? I mean, you never know who may be looking, but you never know who may come across them by accident or anything else like any other software. So it could be employees, and I just had a couple pictures here. That guy looks kind of curious what he's doing. Hackers, the ones up to no good, which according to how you look at it, black hat, white hat, gray hat, whatever. But it's kind of the typical evil-looking, cartoonish, evil hacker. I don't know. Kind of looks kind of cool to me, but I don't know. Security researchers, security professionals, according to how you interpret it. We know everyone here has at least 6 or 7 monitors in their workstation, so this guy's a clean representation of all of us here. And then, really, I found out you don't even have to have a lot of experience with dealing with security vulnerabilities. You can come over, you find them by accident. A lot of people do, but anyone that cares to look could find vulnerabilities in Scada software. It's insane. So, I guess I kind of moved a little quick here, but dealt this to kind of the middle of my presentation. I want to introduce Sploitware. Sploitware is, well, I started out, I was finding all these vulnerabilities in Scada software, and I was like, well, what am I going to do here? I kind of, I thought about writing Metasploit modules for them, to deal with the exploitation part, which is great. You can interchange payloads, you can, host, you guys are familiar with Metasploit, you know what it can do. But I was like, well, kind of bored, so maybe I want to start a project here. And never really wrote a framework before, not in this sense, not a penetration testing framework. So I was like, well, I had some code I could reuse and start on a new project. And I was like, well, I want to learn some stuff too. So I just basically in my spare time created Sploitware. And Sploitware is just a framework designed to specifically penetration test Scada systems, more specifically the software side of Scada systems. And I've used it I haven't used it, of course, in any protection systems. I just used it in my lab with my test systems. But I found you can get reliable exploitation just by, even reusing payloads and things like that. It was pretty easy to design the framework, and I just kind of put some things, I guess, similar to concept of Metasploit canvas, but it's focused on Scada software. And I wouldn't dare say it's anything close to Metasploit or Canvas, but that was my original idea when I wrote it, something that I could use to check Scada systems for vulnerabilities. So it was pretty nice to do. It can check the systems for the potentially vulnerable software. I've written some local checks. It can test remotely, if there's any version strings that come up, or it can detect the headers in the requests. Exploitation is optional but readily available. Like I said, the point of the framework is not just exploitation. That's what kind of the Metasploit was. Metasploit can check with them too, but it's kind of just, if you go into a pen test and say, hey, we got some Scada systems running here, we've got some software running as well on them, of course. What can we find out that's vulnerable, and what can we see, what can we exploit too? So it has checks. It's also kind of added in an auto pwn feature, which I thought is pretty necessary for any exploitation framework. It's pretty cool to do. You can just hit the -A and it'll go through and check for all the vulnerabilities it has in the database, and if it finds any, it'll exploit them. But the payload, it just has one payload right now, which I haven't really done much development on it recently, but it just adds like a user, like exploit, password, where, something like that. You can use anything. You might have to adjust the exploit for some of them, but anyways. But like I said, the point of it's not just for exploitation. The point of it is to, it has local checks, remote checks. It can, just a brief way you can check the Scada environment for anything that may be vulnerable. But the exploits are 0-day, and I haven't worked with any of the vendors yet, but I plan to in the future. But for this, they're just kind of let you know, kind of the post-audit. The pre-audit would be, before they shipped it out. I kind of do like the post-audit, like the vulnerability research with them and see, what exactly is vulnerable. And everybody loves 0-day. And the methods I use for identifying the vulnerabilities. I went from manual testing, like I said, some of them actually, when I first started looking at them, I just wanted to look at the file format briefly, through a hex editor or something, before I dug into it deeper. So I just opened a hex editor and I was like, well, I wonder what happened if I, curiosity gets the best of you. What if I happen to enter a long string here, or changed, this value to an FF, or, just simple auditing. And I found that after I saved it and ran it with the program, it would crash. I was like, wow. And then, you do crash analysis after that. And some of them actually vulnerabilities. Some of them, like buffer overflows, like easy, direct EIP override, easy. Some of them were memory corruption. Some of them were kind of harder to exploit. Different kinds of memory corruption, maybe pointer corruption or something like that. But it was really easy with the manual. That was manual testing. And fuzzing, of course, and any file format fuzzer can set it up to run the application, log the crashes, things like that. So I didn't actually use much fuzzing for the exploits in Sploitware. It was just too easy. Like I didn't even need to. Like I found a number of vulnerabilities just by manual testing, just playing with it. That's how easy it was to exploit. And then some was reverse engineering. I don't know if you guys seen, Sakuna kind of dropped my 0-day a few months ago. I was reverse engineering the EDS file format. And I just kind of went through a brief example. It actually gave me the error messages. I didn't even have to reverse it. It would actually give me the error messages to properly format the file. And then I went into, after I seen that, I was like, I don't think it's giving me everything, so I wanted to reverse it and see what other options were available. So I went through and done that, and I found a bunch of, same buffer was vulnerable, to a bunch of, it was, I think, a Unicode buffer overflow. So I just went through, found it, and then I didn't really post any details yet because I hadn't contacted the vendor or anything. And I just kind of wanted to do an example of, kind of black box testing and then going into reverse engineering. And then somebody, apparently, I guess it was my fault too, they knew what the EDS file format was, they knew what programs used it in Scada. So they, Sakuna, I guess somebody contacted Sakuna and told them about it, and they dropped my 0-day and stuff, but it happens. Excuse me. Okay, so that was the methods. It was really, I didn't use that much reverse engineering just because it wasn't necessary. I like to reverse engineer just to do research sometimes, but most of the vulnerabilities came from manual testing, like manually changing variables in the web parameters, or changing file formats, or just connecting to the server and sending a long string. Like the exploit I'll be demoing today, actually the vulnerability is I guess on receive. It just receives. It doesn't even format the buffer. The vulnerability is in receiving all the data into the input buffer. So I didn't need anything. I basically just connected to the server, and sent the long string and crashed. And then I ran it in WinDB or Immunity. I can't remember what debugger I was using then, but install. I was overriding some other variables too, and I kind of backed off on my payload a little bit, and then I found out I could get EIP override. It's easy. So all these bugs were really not challenging at all to find. Some of them, like the integer bugs, were kind of, I don't know, they were harder to analyze and find, I guess, because you can just manually send -1, negative whatever, or a large value 65536 or whatever, 65535 whatever, and find them. But it's just really easy. And the research and development findings I found, I probably went through the process over, I don't know, 3 or 4 months, just on and off, looking at different Scada software and finding vulnerabilities. And the